Okay, we've got this function here. We're going to find the equation of a tangent line, and then we're going to find the equation of a perpendicular line or a normal line to our curve. So let's think about what this graph looks like real quick. This is square root of x shifted 3 to the left. You should know how to graph this. Like, you shouldn't even have to think about that. You should just graph it. And maybe I should have drawn it a little curvier, but you know what I'm graphing. And maybe let's extend it out here a little because we're going all the way over to 13. So what we're finding is the derivative at this point, which will tell us the slope of the tangent line at that point right there. So we might as well go ahead and find that y value right there. F of 13 will be square root of 16. That's 4. That's not the slope of the line. That's the actual y value. To find the slope of the line, we find the derivative. So f prime as a function will be limit as h approaches 0 of f of x plus h minus f of x all over h. Now we could do this at a single point. I could just use 13. I could immediately find f prime at 13. I find it much easier to find the derivative as a function and then plug in 13 at the end. Okay, and there's going to be a lot of algebra in this. Prepare yourself mentally. So limit as h approaches 0. F of x plus h means rewrite the function, but now instead of writing an x right there, I'm going to put an x plus h. Don't forget that plus 3. That's part of the function. Minus the original function. This is f of x plus h. This is f of x, and that's all over h. Okay, on these radical problems, you got to multiply top and bottom by the conjugate of whatever your radical is. So we've done a couple of these. I'm going to go through it kind of quickly. So the conjugate of this is leave everything alone, but change that sign. If this were a plus, I would make it a minus. Because it's a minus, I'm going to change that to a plus. Plus. And I have to do that top and bottom. Otherwise, I'd be changing the problem. Oops. It's an h plus 3 plus root x plus 3. Make sure you understand all that. Okay, now we just clean up. Leave this bottom factor. Do not distribute there, or you're just going to have to factor it again later. Don't forget to write limit as h goes to 0 on every step. All right, now we FOIL. Square root of junk times square root of junk is just junk. The outers and the inners will cancel out. That plus that will be 0. You should check that on your own, but the outers plus the inners will give me 0 here. And then the last. Remember, we're doing FOIL. Last, square root of junk times square root of junk is just junk, but I've got a negative times a positive, so I'm going to have a negative x plus 3. And that's all over h. And I distribute that negative. So I have x plus h plus 3 minus x minus 3 all over h times, oh, I knew something didn't look right. I forgot to write all this stuff down here. So I'll get my parenthesis there. Still got all this junk down here. Okay, the 3's cancel. The x's cancel. I'm just left with h. That's going to cancel then this h. So I get limit as h approaches 0 of 1 over root x plus h plus 3 plus root x plus 3. Now, a lot of times students get here and they get confused. They don't know what to do. Anytime you're trying to take a limit, what you would like to do is just plug in your value. I wish I could have just plugged in right here at the beginning, h equals 0, but you would get 0 over 0. You can't plug in until we've canceled that h. Now I can plug in h equals 0. That's the last step, and that's where students forget. Plug in h equals 0. So I get 1 over root x plus 3 plus another root x plus 3, because that h is 0. So that's 1 over twice root x plus 3. Now I can find the slope of the tangent line at x equals 13. So f prime at 13 will be 1 over twice square root of 16. So that's 1 over 2 times 4. That's 1/8. Now I can find the equation of that tangent line. So remember, here's my actual point, 13, 4. So I've got this graph. I'm going to reproduce that graph right there. It has this point, 13, 4 right there. And I know the slope of this tangent line is 1/8. So I know a point on the tangent line itself, and I know the slope. I'm just going to use point slope form. Remember, point slope form is y minus y naught equals m x minus x naught. Where this is a point on the original, a lot of mistakes happen here. X naught, comma y naught is on the original function, not the derivative. The only thing we get from the derivative is the slope. So just plugging all that in, I get y minus 4 equals 1/8. That's what the derivative gave me. X minus 13, not 3, 13. There's point slope form. I'm usually happy with point slope form because then I don't have to combine any fractions. Like I've done all the hard work. I've got the equation of a line. But a lot of times in the homework, they'll want it in slope intercept form. So this is point slope form here. Slope intercept form is y equals mx plus b. So now I just got to clean up a little bit. So let me make this all just a little smaller. So I got space here. So let's clean this guy up a little bit. Distribute that eighth. So I'll get y minus 4 equals 1/8 x minus 13 over 8. Then I got to move this 4 over. So y will be 1/8 x minus 13 over 8 plus, I'm going to go ahead and convert this to eighths. That'll be what, 32 over 8? That's 4. So let's see, 32 minus 13, I think is 19. So you guys will definitely want to check my arithmetic here, but I think we get 19 over 8. Now we could check and see if this is right. We could check for both of these. Both of these should pass through the point 13, 4. So if I plug in 13 plus 19 is 32 over 8 is 4. And it'll obviously work here. If I plug in 13, this is 0. I just get y equals 4. So here's slope intercept form. Here's point slope form. Now, what if we wanted, we're going to get fancy here. We got this graph. Here at the point 13, I don't want the tangent line. I don't want this line. I want the line perpendicular to that. I want this to be a right angle. I want the equation of this line. So you got to think back to college algebra. What do you know about the slopes of perpendicular lines? Slopes of perpendicular lines are opposite reciprocals. So this guy, the parallel line, had slope of 1/8. The perpendicular line, his slope will be the opposite reciprocal, -8. And I still pass through the point 13,4. So now I know the point, or I know a point, and I know the slope. So in point slope form, I just plug in the 3 pieces of information I know. I know that's 4. I know that's -8 and 13. So y minus 4 equals -8, x minus 13. Now I could go ahead if I wanted to and write that in slope intercept form, but honestly, for most of the semester, I'm going to be happy with point slope form. And that's a good place to stop.